morning and welcome to the NLGI webinar this morning in regards to our new high performance multi-use grease, otherwise known as HPM. For those of you who might not know me, I am Crystal O'Halloran, Executive Director for NLGI, and I just wanted to take a moment to thank you for joining us today. We've had a group of dedicated industry professionals working behind the scenes on this new grease specification, and we're really excited to share with you where we are in the process today. And not just where we are in the process, but details within the specification as well. Just a couple notes before we get started. We will have 4 presenters today talking about different sections related to the HPM specification. And at the end of each of their respective sections, there will be some time for Q&A. So if you'd like to submit a question along the way, we certainly encourage you to do so. The best way to do that is to take your cursor and kind of scroll over the very bottom of your Zoom platform. On the right-hand side, you'll see a little bubble that says Q&A. If you click that, you're welcome to type in a question right there on that field. You may have noticed when you joined today's webinar that you are muted, and you will remain that way for the duration of the webinar. So submitting a question through this Q&A field is the best way to do so. Please note that we're going to have over 250 of you on today's webinar, so we will certainly try to address as many questions as we can today. But in the event that we don't get a chance to answer your question, we will have a slide, the very last slide of today's presentation will include contact information for our 4 presenters as well as myself. So if your question does not get addressed and you're still seeking an answer, we encourage you to reach out to one of us. Without further ado, I'd like to turn it over to our first presenter today, Mr. Joe Kaparick. Joe is the current past president of NLGI and also the senior advisor of Grease for Afton Chemical. Joe?
Thank you, Crystal. So I have to say that it's a lot less intimidating to talk to a crowd of 200 people plus while sitting alone in a conference room. A little bit easier without the bright lights shining in your face or anything, but I do appreciate the fact that we do have probably a wider audience today because of the fact that we're not in Miami. I think it looks like we certainly have a pretty wide number of people from outside the US, as well as a lot of members and colleagues and friends that I saw looking through the attendee list. So thank you for joining. What I'd like to kind of talk to you a bit about today then is to start with kind of where this all began and then walk you through just a brief overview. And then I'm going to turn it over to the individuals kind of more closely involved with each of the steps along the way to go into some more detail on those areas and hopefully give you a good idea of what we're talking about here today. So 2015, 2016, NLGI board got together to kind of talk about where we were and where we wanted to go. And out of that, those discussions, kind of some long hours, maybe some of you have been through these with your own companies, but I think it's a good idea to do this. And it was a good idea for us as NLGI to kind of talk about what we wanted to do and what we wanted to be for our members. So our mission is to provide resources relevant to the needs of the global grease community. And as part of that, then our vision is that we would be recognized as the premier source of support to our stakeholders. So as part of that, we identified 6 key priority areas that we wanted to work on to add value. And I think you hopefully have seen some of those things along the way in the last couple of years, things like basic research grants and enhanced membership retention focus, a lot of key areas that were identified underneath that. But one of the big ones here is communication of NLGI's knowledge-based resources and certifications. And underneath that, one of the specific goals was to modernize and update the GCLB program. So if we look at GCLB itself and the certification, I think most of you or many of you probably are familiar with GCLB. You're familiar with what it means. We license greases through the GCLB performance classification and grant the certification mark to be used on greases. So that GCLB specification was developed and published in 1989, but began in 1968. So quick math there is 21 years to get that published and out to the global community to use. Now, obviously, some of that, though, it was pretty groundbreaking at the time, had to develop a lot of new tests and measurements that weren't available at the time. So quite a bit of that was on method development, et cetera. But still a long time to get a specification out. And it's been a good 30 years now since that specification has been published. It is internationally recognized. It's used by manufacturers and marketers alike to kind of have a conversation about the quality of the grease. Right now, today, as of June, I believe, we have 306 total products that are licensed by 85 different companies. So obviously a lot of value there to the stakeholders to have that conversation about quality of grease. The majority of the greases that are out there today do meet GCLB, which is kind of the top tier of the entire specification system there. It's originally, though, it's an automotive chassis and wheel bearing specification, and it's not really used as such today. I don't believe any of the original equipment manufacturers, any of the manufacturers of automotive parts are specifying that. But it's because I think that it's moved kind of beyond that. So there's advancements in materials, technologies, the applications where greases are used, but GCLB still finds a big place in that as kind of a mark of quality. And that's the discussions that we've had then within NLGI, is how do we kind of upgrade that and how do we move to the next generation? And that brings us then to high performance multi-use grease specifications. And this is kind of where we have the goal here was to define these new grease specifications with higher performance and better utility for the market in general. So it's not going to replace GCLB. GCLB is still called out in some OEM specifications. Use a good quality grease such as GCLB if the specific grease is not available. Those kinds of things are still in specifications and still then obviously of use to the OEMs and to the marketers to have, again, have that conversation about quality of grease. So that being the overall goal, what we wanted to do then was kind of define these greases to meet the core HPM specification. So that core specification is a good high performance multi-use grease that will be useful obviously in multiple applications. And then on top of that, to have subcategories. So if you have, say, an application that needs increased water resistance, you would meet the core HPM specification and then add on additional water resistance for that particular grease for that particular application. As a marketer, you could aim your products at specific areas based on those claims. And as a user, you could have that conversation then with the manufacturers as to what you need in this specific application. So the five different subcategories that we've identified at this point are water resistance, high load carrying capacity, saltwater corrosion resistance, long life, and low temperature performance. We're going to talk in detail about these as we go through the day, but this is just kind of the high level where we started. So to do this then, we really had to put together a governance structure, kind of understand how this is all going to fit together. And again, we're going to go into more detail on each of these areas, but Dr. Gareth Fish started off these conversations at the working group meetings, which some of you may have been attending. At the NLGI annual meeting, we have the working group meetings typically on the Sunday. And in 2015, we started the conversation about what would this look like? What should be included? What are the types of tests that should be in this new specification? And that kind of grew and evolved until last June, when we had a little bit more power behind it. We had started to get some of this impetus going to push this forward more. We brought a plan to the board to make this a reality in a much quicker time frame. And as part of that plan, we worked with the Center for Quality Assurance, and Mike Kunselman is going to talk through that today. But Mike it was hired by NLGI then to help implement this and then to help with the auditing and certification after this is rolled out. This is going to add quality to the products that we are delivering and to add to the value of the certification that you have on your grease. As part of this, we also then formed the Grease Specification Steering Committee, and that steering committee involves Mike and his company, as well as the NLGI, the board and membership, people from within the grease industry, to make sure that we had a broad spectrum. And Mike will go into more detail on how we did that and what that looked like. And then we also realized, though, that we needed a good technical consultant, somebody who really knew the grease side of things. Mike is great at the auditing and project side of this, but he needed somebody who could talk grease. And so NLGI hired, we put out a specification for a technical consultant and chose Chuck Coe as our technical consultant to kind of be the grease side of the equation working through this. And I have to say that Mike and Chuck they have done the majority of the lifting and carrying of this throughout the last year. That work really shows up here on one line, but was probably 80 to 90% of the work that's been done here. And the steering committee has been great with calling in regularly, taking time off from their day jobs to be a part of this and to help with the actual steering of this, to get this to the place that it is today. And then the workshop that many of you may have attended in March to kind of see where we were at that point, and to help really in March was much more interactive in terms of getting people's opinions, doing breakouts, understanding that whole the whole industry portion of this that maybe we hadn't had to that point. And then the finalization meeting is basically today. We had hoped to do this live in Miami, obviously not possible, but I think, again, probably a broader audience here today because of that. And that brings us to where we are today. So going forward from here, we will need to get some final fine-tuning that Chuck will talk about when he gets to that portion. But the NLGI Board of Directors then would need the final approval to go forward with this. And then starting, and once that's what is projected to be in September, we have a September board meeting. And then from that through the end of the year, pretty much getting the marketing task force for the HPM specification to kind of get ready to roll out the specification, which we are targeting for January of 2021. So that's kind of the overview from here. And as I said, we're gonna kind of go into each of the different sections along the way. But I would pause at this point to see if there are any questions that anybody has. Keeping in mind, I may skip some of those forward if they're going to be covered later on in the process. And of course, now I'm not seeing the question and answer section on the bottom of the screen.
Doesn't look like we have any questions for you at this time, Joe.
Well, good. That's perfect then. All right. So what we're going to do then is kind of use the timeline here as a guide for the webinar today. And we're going to start with some more in-depth discussion then on the Grease Specifications Working Group. And Dr. Gareth Fish is the one who chaired those to start with in June, and has remained a part of the steering committee to date. And he is now going to take over and talk about how some of that developed. Gareth?
Good morning, ladies and gentlemen of the grease world. This is Gareth Fish from Lubrizol Corporation, and I'm going to talk you through some of the things that we did. So the automotive service grease, as was said earlier, it was a joint effort between NLGI, ASTM, and SAE. It was led by the late Tom Badura of General Motors Research Center in Warren, Michigan, and him and his team did a massive effort. They developed 8 new tests. They defined, they did testing, they did a huge amount of work and launched it in '89. And there was a big presentation at the NLGI annual meeting in 1990, which is the first NLGI meeting I actually attended. I saw Tom Badura present about the specification. I thought it was interesting. So it basically covers the relubrication of chassis systems and universal joints, which is category L, and wheel bearings in category G. Okay, so talking for the new specification, we had a discussion at the ASTM B04 meeting. The title of that subcommittee of ASTM is Automotive Greases, and we met in Norfolk, Virginia, and we were looking at the reapproval of the standard. And one of the issues was about a change to the elastomer, and so we were moving from the different elastomers. So net result of that was we had a discussion, and then we agreed to modify the standard to update the elastomers, and from there we then moved on to any other business. And one of the members there, I can't remember who it was, raised the issue about the standard and the fact there were some test methods within the ASTM D4950 that had problems with repeatability and reproducibility. There was also discussion about some of the hardware, and as you probably gather from the fact the committee started meeting in 1968, that the componentry used for wheel bearings was based on a 1970 General Motors passenger car, and so some of the tests were thought to be less relevant to today's modern cars. And so we had a discussion about where we needed to go. And so the discussion led to the suggestion that we set up a working group to review the specification, review the test methods, and to define a path forward. So as you can see from this list, we went through in the committee through the 12 tests that are covered by the NLGI GCLB specification. And we concluded that the tests listed in green on the left, cone penetration, water washout, oil separation, rust testing, 4-ball wear, 4-ball EP, those test methods all had good repeatability, or as good as repeatability and reproducibility as grease test methods have, and there were no issues with hardware and other issues. As to the other tests, they were some problems. The 2265 and D566 dropping point test methods both use mercury and glass thermometers, and at the time the EPA was telling commerce that they wanted to get rid of mercury and glass thermometers from commerce, and so we needed a new method of measuring temperature, and that is still being worked on, because the way the thermometer measures the temperature, it influences the temperature. And if any of you were at my NLGI presentation last year, I described a lot of the issues that we've got with dropping point testing and with trying to measure temperature. We also looked at 3527 grease life. The repeatability and reproducibility of that test method is poor. The grease leakage test, again, it uses the same apparatus as the 3527, and the question for that is that test method still relevant in today's world? Fretting wear was known to have a lot of issues, especially with repeatability and reproducibility, and there were also some issues related to equipment and the supply of bearings. The elastocompatibility, which kicked off this original discussion, the 4950 does not control the elastomer used, and it belongs to the SAE Aerospace Materials Group, and they had made changes and not informed anybody, and when people went to buy the elastomer, they found it was not available. And so the big concern there is availability of the elastomers, a lack of control of the elastomers, and the other feature was that were the materials, because they're aerospace materials, were they relevant to the type of seal materials used today? The other final test was the low temperature torque. This is again a wheel bearing test method, and so is that the right test method moving forward? And also it's at -40, which is typically much too cold for normal applications. So what we did was we modified it again in 2014, and it was reapproved. And again in 2019, Again, we had another change to the elastomer. This is the fourth change in elastomer in the last 10 years, and the method is still valid to 2024. It has currently a sunset date of December the 31st, 2025, but if it's going to be renewed, it will have to be renewed in 2024 and 2025 before the end. One of the things we saw and heard was that equipment makers and vehicle makers who use the standard suggested it needed updating. One maker said that when the standard came out, it was above most then available specifications, but with the world moving on and the specification staying static, standard grease had moved above and beyond GCLB, and now it was seen as a minimum performance. And the last thing we did, the supporting test methods covering dropping point, high temperature grease life, fretting wear, elastomer compatibility, we've set task groups or activity groups looking at how to improve those test methods within the HPM Grease subcommittee. So in 2015, I said that it was time to raise the subject of revising and reissuing or doing something to modernize GCLB. I'd felt that the number of approvals had become static. There was no significant increase in approvals. And so I set up a town hall with NLGI, and we went through some ideas, and that was then presented to the NLGI board of directors in early in 2015, and they decided to set up a working group to either upgrade or define a new specification. And at the time, I thought that it would take probably 10 years to go from where we were to where we are. And I'm amazed that we've gone so far in the last 5 years. And I was asked to chair that subgroup. So what we did was we looked at what was the thing being used for. So the current premise that we need a lubricant grease performance standard for automotive service greases for passenger cars and light truck is distant from reality. If you look at a passenger car today, I drive an Audi A6. The only componentry that needs to be re-greased on there is the door hinges. My old technician, he had a 2004 F-150. He required to re-grease periodically the suspension arms. In the latest models of that vehicle, there is no re-greasing points. 90% plus of applications are sealed for life. And as I said earlier, we discussed with more OEMs who specified GCLB, suggested that the current performance standard is inadequate. So we also looked at what was currently approved. So there was around 250 GCLB approved greases, and I went through each of the specifications, the ones I could find that was open on the web, and concluded that nobody went for just a regular GCLB. They got GCLB, but in terms of properties and things, they also claimed either better water resistance, better load carrying, and better salt water resistance. So we talked to people. I went to a meeting with some trucking folks and discovered that the NLGI LB specification was still widely used by the trucking industry for chassis lubrication, and the LB seemed to be an important part of this. Most trucking firms specified and used LB greases for those applications, and the message that I got was that LB was still important. We also saw that GCLB was still widely specified for many people. And so after a discussion, we decided that we would leave that as it was, with the potential to review it when the specification next comes up for review in 2024 to decide where to go from there. And what we decided to do was to pursue 4 subcategories. So we want a general grease specification, which then morphed into HPM, and then 4 subcategories, which were better water resistance. So it meets all the requirements of HPM, plus has better water resistance, or better load carrying, or better salt water resistance, or had longer life. So that was where we're at. And at the end of the meeting, we had specifications, we had information, and I'm now to the point where I'm up to receiving any questions. So I've received 1 question. The 5th category of low temperature is missing. Yes, that will be covered in Chuck's presentation. Okay, so the next question just come in. Did you define the testing requirements of the 4 subcategories? Yes. So in the documentation that was shared with participants, there were proposals and some blanks, some uncertainties, but the generally information for the 4 original categories as listed on this slide were defined and discussed at the meeting. Okay, so in the absence of any additional questions, I'd now like to introduce Mike Kunzelman from the Center of Quality Assurance to take you through the next section. Thank you, everybody.
Thank you, Gareth, and hello, everyone. I'm Mike Kunzelman, and from the Center for Quality Assurance, or CQA for short. And as Joe mentioned, NLGI hired CQA to facilitate the creation of the specification, as we had previous experience with similar work. So I'm going to cover how we got to where we are today. And on the right side of the timeline, picking up where Dr. Gareth Fish handed off, you can see that CQA was hired in July of last year, and NLGI also recruited Chuck Coe, as Joe had talked about. And Chuck brings over 4 decades of grease experience to provide the technical leadership on this project. And Chuck and I have worked closely for over 8 months to facilitate all the experts who've participated in the creation of this specification that we're seeing in this presentation today. And then in the other yellow box on the right, you see all the work that's been going on since last fall, with the culmination of the workshop in March to review the status. And I'll cover the details of that in a few minutes. And the other part of this whole process is the specification steering committee shown on the left as part of the governance structure. And this steering committee was created to be the sounding board and decision maker as we drafted the specification. So let's get in and start to talk about how the specification was developed. And the high performance multi-use grease specification really starts by collecting feedback from experts in the industry. Many of these experts are dialed in today, and we really appreciate your time and knowledge that you have shared. My role as a third-party observer to the grease industry, my observation is really you all should be really proud of what you're doing through NLGI. It's very impressive, and I've really got a chance to see what you all are doing to keep global economies moving. So NLGI wanted us to target users and equipment manufacturers who specify grease. So we started with a draft specification that the specification working group had developed, the team that Gareth had been leading over the years. And then Chuck Coe and I went out and requested feedback. And as the next slide shows, we took this draft specification, and anywhere that there was not clear consensus in the industry, we would highlight the property being tested, the associated test method, or even the limits. And we would keep asking those things that, you know, what's important to you, the expert in the industry. And we really went across many industries, not, you know, where the grease was being used. And this clip of the draft specification was from October 2019. And we basically constantly updated this draft based on the interviews that we had. And as we were getting ready for today's presentation of this, I counted 33 different versions of this document that Chuck and I had worked with you know, input, people for feedback, as well as the steering committee. So in the interviews, anything was available for discussion or questioning based on the person or company's experience. But we had this underlying theme, challenging but achievable for the new spec. And this theme had come early on in discussion with the steering committee. And we really used this to say, we need a realistic specification that's challenging, but we need something that's achievable for the grease manufacturers. So through the months of interviews, we really had this team approach. Chuck and I often discussed on a daily basis what we heard, what we thought was missing, what we should go ask next in the next interview. We always look for balance. If one company said X, we try to get a confirming opinion or a contrasting opinion from somewhere else. We were very thorough. We cross-referenced a lot of different documents or people in different interviews. We asked for data when it was available, and we kept asking why. One of the early things that came back was, don't change GCLB. Don't try to upgrade and fix GCLB. Try to make a new specification that really was a multi-use grease. And I really want to stress how we use this feedback throughout the process with a couple of examples. You know, as we were getting into the final stages of the feedback, someone on the team made the comment that they didn't think fretting wear was important. And Chuck and I had gone back to an interview around heavy equipment and talking about a common problem where fretting was an issue when equipment got shipped around the world. And resistance to fretting was really a must for the new specification. And so you'll see fretting wear in the specification. Another example was the low temperature specification. This was not originally one of the subcategories, and one of the questions that came into Gareth, what about low temperature? That actually came up as we were talking with different folks in the industry, and we wanted to define this, and we really debated around what temperature should we be testing at. So we didn't want it to be Arctic conditions, but we wanted it to be winter in the north, where you may have a central lube system sitting outside of the plant that needed to pump grease throughout the winter. And we even challenged things like what bearing geometry. Should we be using a roller bearing or a tapered roller bearing in the grease specification? What would be the most applicable? So that's really examples of how we use the feedback. And again, that feedback was just very, very valuable. So all of this interview information would make its way via Chuck and me to the specification steering committee that we've been talking about. And we would convene this committee at least one time per month. And they would hear the feedback. They would vote on proposals that Chuck and I would prepare based on the interviews. And this team of industry experts, this relatively small team, but there's between 10 and 15 people on this team. And it was really critical. So let me talk about this team in a little more detail. So the initial committee was made up of members from the NLGI's executive committee and also Dr. Fish, who led the specification working group. And their push, as mentioned earlier, was to gather more feedback from grease users and specifiers. And in order to give that segment more of a voice in the steering committee, we actually expanded the committee to include OEMs who would be specifying grease or using grease in their equipment or the bearing manufacturer. And then just to make sure that we maintain balance in the decision making, we added additional grease manufacturers. And you'll see that the yellow part of the pie, there were specialty grease manufacturers, but then we also added some mainstream grease manufacturers that we labeled here as high volume grease manufacturers. One of the things that I skipped over was, we did hear a comment early on of don't set a specification that requires a proprietary additive chemistry. And that was really one of the things that moved us towards getting more grease manufacturers into the committee. And, this really is only one person, this additive supplier pie. If you removed one person out of that, it would be much more balanced as far as the size. So I think we went at this of having multiple additive suppliers so that we got differing views, that they would have differing chemistries that they would work with on an ongoing basis. So that gives you, the interview process, the sounding board that we had, accountability for Chuck and I moving forward. And we had a lot of information going into March. And we were planning to have this workshop, and I've got a picture of the room where we were going to have 4 different groups plus a virtual group. And we had 45 participants signed up for this. And we basically made it a virtual event due to COVID, but that allowed us to include a participant from China, India, South America, in addition to who we had planned to be there in person. So we basically took what we thought was a fairly complete specification at the end of March, and we studied it in microscopic detail over 6 hours. Again, we had the 45 participants broken out into 5 groups. And one of the questions that, came in was, well, why did we not include oil suppliers? And I think some of these grease manufacturers are actually vertically integrated back into the base oil supply. But the only other reason I'd say is we didn't have anyone step up at the time saying that. The other thing is we really had good representation of different chemistries. And so folks who had a good understanding of different base oil chemistries, I think we really did have a decent representation of that, even though we maybe didn't have a formal, specific base oil supplier, as part of the steering committee. There may have been base oil suppliers here at the March workshop, but it was these real life experiences that were key inputs and really moved us in certain directions. And so anyone who joined the workshop at the end of March will see many things today that were really discussed in a lot of detail just 2.5 months ago. And one of the things that was decided at this time was that we were going to put the long life tag, this, having the high performance multi-use grease core spec, but then having a long life specification part of it, that we would put that on hold because we didn't see that the test development would be ready for Q1 2020 when we plan to launch this HPM Grease specification. And Joe will talk more about that timing in the wrap up today. But the key part of organizing this feedback from these different breakout groups were what we call the table captains. And they knew going into this that they would have to represent their team throughout the specification process. And trust me, they have continued to do that, pull up their notes. We've continued to pull up the notes from that workshop right through this process of what you're seeing today. And so basically we had this feedback from the workshop then, where everything had been gone through in great detail. And we took all of that feedback back to the steering committee. And you'll see in the steering committee, there's a happy face and a frowning face. But the table captains summarized all of their team input. Chuck and I then spent about 8 hours combining all of that information and looking for consensus. And we definitely not everywhere were able to get consensus. On this next slide, you'll see about a quarter of the tests, the methods and limits we could get consensus on. Everything else, and you see kind of a cutout, was looked at line by line, and we really went through and tried to get consensus. And several times we had to go back on many tests and actually get data and have data submitted that we could then analyze and make some decisions around the tests. So as you can see by the coloring in the spreadsheet, there definitely was not consensus on every line item. Ultimately, we did end up with consensus on a lot of things, but many times we would mark something as consensus but not unanimous agreement. And so I really appreciate the opportunity to relive this last year of the process and explain that to you. And I believe that we're leaving the industry with a very solid specification based on the input from you all, the experts in the industry. And so before we transition on to the actual specification, let me just check to see if there's any other questions, and I do not see any. So I am going to hand this presentation off to Chuck Coe, who provided the technical leadership on this project. And as I mentioned previously, Chuck's consulting firm, Grease Technology Solutions, was formed over 10 years ago by Chuck, and he spent several decades at Mobil and ultimately ExxonMobil. And he serves currently on the NLGI Executive Committee and Board of Directors as NLGI's past president. And so with that, I am going to give the ball to Chuck, and you've got it.
Thanks, Mike. I appreciate that. As Mike said, I had a number of years of experience with lubricants and various greases with Mobil Oil, which then became ExxonMobil. And about 10 years ago, I retired from that awesome organization and formed a consultancy, and I've been involved in grease ever since. So my life has been well greased. So what I'm going to do is talk about the specifications. I've got 3 slides discussing the HPM Core Specification, and then I have 1 slide each on the 4 tags, which are the corrosion resistance, water resistance, high load carrying, and low temperature. So what I will do is, I think I'll talk through the first 3 slides and all the way through the HPM Core Specification, and then pause to answer any questions at that point before moving on to the other specifications. So what you see here is page 1 of 3 of the core spec. What I've done is I've highlighted in sort of a light blue-gray there the tests that also appear in the current GCLB specification. And as I go through, I'm going to compare and contrast the HPM specification and the additional 4 specifications to the GCLB in terms of what tests we've added that are different and more severe, and what tests we maybe have the same test as the GCLB, but maybe a more strict limit, okay? And then there are another couple topics that I'll address as we're going through here. So carefully using my cursor here. Cone penetration of lubricating greases, the 60 stroke work penetration, which I imagine all 250 plus people on this call are familiar with. ASTM method D217, quite an old one. What we've got here is limits from 220 to 340. And what that does is allow for greases that are number 1 grade or number 2 grade or number 3 grade or any intermediate grades, which sometimes people refer to as a 1.5 grade or what have you. So we're allowing the full range of consistency that we do in GCLB today. So that's identical. The next test is the cone penetration of lubricating greases on a prolonged worked penetration basis, 100,000 strokes as contrasted to the 60 stroke work penetration. The key here is that GCLB, you can see it's in white, so GCLB does not have this test either in the GC or the LB portions of the specification. So this is, and you'll see throughout, the GCLB does not have any structural stability testing, which I can't explain that or why it was less important back then than we think it is now. But I think everyone recognizes the value of having good structural stability. There was considerable work on this I didn't do that. Somebody advancing my slides? All right, let me try and go back. We'll try to go back. Okay. All right. If I did. Okay. I must have breathed on my keyboard. So this test had a lot of discussion. This is kind of where the conversation that Mike referred to around challenging but achievable. There was considerable energy around this being too severe and that maybe we should have plus or minus 12%. Then we discussed having a 10,000 stroke work penetration with plus or minus 10%, but we did come to consensus. Painful process that Mike outlined. It was not always easy. Took a lot of discussion and in some cases, as he mentioned, additional data generation to get ourselves where we were comfortable with our proposed limits. The next one's elastomer compatibility of lubricating greases. Gareth mentioned this as being the initiator of why the GCLB specification was being re-examined because of issues with that test and with the elastomers in that test. So where we are today on this is we have specified NBR standard elastomer per ISO 13226. This is different NBR elastomer than is used in the GCLB. And while I mentioned there in the actions that the reference elastomer is still to be finalized, the elastomer task force that worked this issue specifically has pretty much landed on the ISO 13226 specification, but now we're working on making sure we've got adequate sources of supply for this elastomer. So another change from GCLB here is that in GCLB, we do not specify 168 hours at 125C. In fact, we've increased the time duration and lowered the temperature. So we need to collect some data to validate this. So when we get the elastomer finalized and in place, we say something there under actions called road test to validate limits. So some of these tests where we simply do not have the data to say these are the right limits. For instance, we don't have data on this new elastomer at 168 hours at 125 C. We are going to do something called road testing, which is to say we will run some, have people that are participants or interested that make greases or have greases in the lab or commercial greases to take a look at some of their products and determine if they think these products will be candidates for the HPM specification, and then have them run this and some of the other more less well-defined limits in this road test. So we'll gather data so that we feel comfortable that under these conditions with this new elastomer, that the limits that we have specified there are the appropriate ones. Moving on, oxidation stability of greases. This is another one that is not in GCLB today. We landed on the conditions of 100 hours at 100 C pretty quickly. The group was very aligned on this, and the proposed maximum of 35 kPa, which is approximately 4.9 PSI. This was a test where we had pretty good agreement right away and didn't have to work this in a lot of detail. The next one's water washout of lubricating greases. And again, this is a test I'm sure most of you, many of you are familiar with. Standard condition 60 minutes at 79 C, because the temperature can be varied in this test. And we are specifying a 10% maximum. And you see by the blue shading that this test is part of GCLB today. However, it is 15% maximum in GCLB. So here's an example of a test where we are using a test that is in place currently on GCLB, but we're moving to more stringent limitations. All right, let's see if this is, there we go. Okay, second page of the HPM specification. So low temperature torque is not currently in GCLB, or at least this low temperature torque test, the D1478. We have a wheel bearing low temperature torque test at minus 40 C, which, as Gareth mentioned, we decided to move away. I believe Gareth mentioned it, or Mike, move away from the 1974 wheel bearing from a Ford vehicle, I believe, to something more representative of industrial applications. So we've got the ball bearing low temperature torque test specified. Again, we do not have a good body of data at minus 20 C in this test to feel 100% comfortable with our limits. So we will be road testing this test as well to confirm that this is both sufficiently challenging but achievable. The oil separation from lubricating grease during storage, the D1742 test, is in fact part of GCLB. It has two different limits, but it's 6% in the GC spec, the wheel bearing spec. So we're making this a bit more challenging by reducing that to 5%. The next two tests do not appear in GCLB. Oil separation, another test for oil separation, the D6184, which we feel is a generally more severe test and adds another perspective on oil bleed than just the D1742. And this test, we've got a limit of 7.0 compared to the D1742 at 5.0, recognizing that D6184 at 100 degrees C is a more severe test. Now we have roll stability as the last test on this slide. And again, this is another structural stability test, which we do not have structural stability tests at all in GCLB today. This is actually one that we came to fairly quick agreement on as well. The standard roll stability test, 2 hours at room temperature with a plus or minus 10% limit, seemed to be very agreeable to everyone on both the steering committee and in the interview process as well. Okay, the final page of the HPM Core Specification. So the first 3 tests are in GCLB, but with different limits. So that, okay. So in the first test is the 4-ball wear test, standard conditions, with a 0.6 millimeter scar maximum. And the 0.6 is the same as today's specification in the LB specification, but it is more severe than the GC specification. Then the next test is the extreme pressure version of the 4-ball test, with a specification of a 250 minimum weld load. This is one, I think if you recall back to Mike's slide where he showed an example of some of the tests that we were discussing, and eventually made a shift in our proposed limits. This is one where we started with 200 kilogram minimum weld load as a starting point. And then after interviews and discussions with the steering committee, we said that is just not really challenging. That doesn't mean very much in terms of extreme pressure capability. So we decided to move it to 250 kilogram, and which was met with pretty round agreement from both the working committee and working group and the steering committee and interviewees. The next one is corrosion preventive properties, the standard static rust test in distilled water, and standard conditions on that, and a minimum pass, which is the same as we have in GCLB today, so nothing new there. And you can't really do anything with that test to make it more severe, either in limits or in test conditions, because it's a pass-fail test, and those are the specified test conditions in the method. However, we felt that that was not necessarily the most challenging corrosion test, so we added the M-Core test, the dynamic ASTM D6138 test with distilled water, which again, it's distilled water. It's not, we'll get to salt water later on, but this test adds a completely different perspective to corrosion compared to the static D1743 test. And again, came very quickly to agreement that 0 or 1 for the 2 bearings was an acceptable maximum for that test. Then we added copper corrosion, D4048. Again, this was a test that was not in the original GCLB. I can't exactly answer that one, I'm not sure, but we feel for industrial bearings, there's pretty good need to have yellow metal protection. So we have added this, and 1B is pretty widely accepted limit that grease marketers tend to claim as a maximum. Okay, so I'm going to stop there. We've got a lot of Q&A. Okay, so what procedure was used to ask for samples? We were not asking for samples. We asked for data from either the interviewees or the steering committee participants. And frankly, I think, I'll say most of the data, but not all of the data came from the steering committee participants in order to develop the limits for some of these tests that we were unsure of what the right limit would be. Were the grease samples sourced for testing and method verification? Were certain types of chemistry selected? No and no. Again, we didn't solicit samples. We've not tested any samples. We are moving into the next phase of this project between now and when Joe talks about the final steps in the project, he'll talk about what's going to happen between now and the board meeting in September when we will seek approval. We will do the road testing between now and then. So that will be our first actual testing to support these limits. And the intention of these specifications, all of them, is to be chemistry neutral. We are not trying, we are trying actually specifically to not have limits that would force you to use a PAO base oil, or would force you to use a certain type of anti-wear chemistry for fretting. So we are trying to be neutral here, and we're developing a performance specification. We're not developing a specification to eliminate or mandate any particular type of chemistry. All right, that one's done. In the specification developed to target a specific chemistry to meet all performance requirements. Again, I think I answered that. We did not target specific chemistries, and we tried to be chemistry neutral. Same question. Done. Why not change elastomer limits to report until the limits are determined? That's a very good question. We had, I'm facing my big screen. Sorry, I'll face the camera. We had a lot of discussion around this, and specifically around the elastomer compatibility. In fact, there was a draft, there were several drafts amongst those 30-something that Mike mentioned. Earlier drafts, we also had tensile strength and elongation at break added to the elastomer compatibility. And again, we don't have the data to support establishing limits, so we were going to just do report only. But then we came back to, what is the specification? If it's report only, who's going to see the data? We want something where you either meet the spec or you don't meet the spec, and you can put the certification mark on your package of your grease and on your product data sheet, or you can't. We shouldn't force people to have to then look up data to see what was report only. So what we will do is we will road test to establish the limits. And quite honestly, these are all going to be somewhat live specifications as opposed to GCLB, which has been static for the most part since 1989. We envision that these specifications will evolve over time and be updated or upgraded. So if there's a problem with a particular limit, let's say the elastomers, if it turns out that everybody's having extreme difficulty meeting a limit, we can revisit it and maybe put it aside. I'm going to address something like that when I talk about fretting in a little bit. So we'll move on from that question. How will the end user ensure that greases of different chemistries meeting the same spec will be compatible in real application situations? That's another really good question. We had a lot of discussion around that, and there was discussion around having compatibility requirements in our specification. We, after a lot of discussion and going around, we decided that it would not be appropriate for us to do that. There's no compatibility requirements in GCLB. There are no compatibility requirements for the most part in most OEM specifications. That's upon the supplier to provide the data to a customer if the customer wants to use a different HPM grease after having used another one. That's the same challenge that exists today whenever you change greases. And it's not really something that we can address properly within GCL, or I'm sorry, within the HPM spec. And in addition, there's a task force working on the compatibility test method, which in itself is not necessarily the best test method, and everybody uses kind of their own means to determine compatibility. How will the end user ensure that greases of different chemistries meet? Well, I already answered that, okay. Does the change in the theological properties, I didn't know greases had theological properties, probably rheological, with the presence of water, does it matter? From rheometer testing, I've observed some grease gets thickeners and consistency reduces. How to evaluate the water resistance property. We're going to talk about water resistance. It's coming up. So I'll get to that one in more detail. 20 kilograms for 4-ball weld, claimed to be named as high performance, sounds very low. Well, 200 was lower. 250 establishes some level of EP performance. 300 was discussed as well. But again, this is a multi-use grease. This is not a high load grease. You'll see that we have a much higher limit when we get to the high load grease. I personally observed a huge change in the rheological property of some grease with water, and we're going to talk about water resistance shortly. Perhaps the performance limits for elastomer compatibility, oxidation, and washout could be reviewed against field samples for elastomers used and greases in typical conditions. Well, and that's what we will do on an ongoing basis after these specifications are launched. We will continue to evaluate real live performance, how our spec looks in a commercial marketplace. Can IP 186 test be an alternative to D1478? While it's similar, it's not a direct alternative to my knowledge. I'd have to pull out some files, and I think I can get Gareth Fish to confirm that. But there are no alternatives. Whatever test we specified will be the test method that's required. And have you considered rheometry as an alternative for D1478 for low temp torque testing? It was discussed at some point very early on. Rheometry is an evolving science when it comes to greases. There aren't too many standard test methods and so forth. And again, we have to consider what test equipment is available to people. That's probably more likely finds use in product development than in something to certify a certain level of performance. And I think, okay, Anuj Mystery piped in and says IP 168 is very different compared to the ASTM method. Well, thanks, Anuj. And again, you have to use the test method as we have specified. What about storage stability, age hardening of the grease? Ooh, that's another really good question. And it's also one that we're not addressing that with the HPM grease at all. I think storage stability tends to be something that the grease supplier addresses, and they put recommendations on their packages and data sheets for best if used by, or I don't know, not expires, but I mean, that's kind of up to the individual supplier. At this point, you know, it's very possible that different technology greases will meet the HPM spec, which will lead to, oh, they can be incompatible. We talked about that. And oh, they may have very different storage stability. And that's really on the supplier to provide that kind of information. And again, there's not really good standard test methods to even include that. It's not really a performance test. It's a long-term storage stability test. We've specified HPM as a performance specification. Suppliers detect storage stability and shelf life. Exactly, I agree with that, they do. All right, got those questions handled for now. So let us move on to the other specifications. And I would mention here, it's been mentioned before, if I get it to advance. I don't know what's going on here, but let's try one more time. Oh, now it went. All right, I think we're there. So as mentioned before, and I'll mention it again, and this is a really key and important thing for everybody to hear and understand. The HPM is our core specification. It's our high performance multi-use grease spec. It's not intended to provide superior performance under extreme conditions of any kind. So we have added these tags. There are 4 of them that we have developed. And the important thing to know is that if you're going to claim HPM plus WR for water resistance, you must meet HPM. The grease has to meet the HPM base or core specification in order to claim the plus WR or the plus CR or any of these other enhancements. So what this is specifying, and what all 4 of these are, this is not a grease for extreme wet conditions. It's a grease with better water resistance than HPM, base core specification. So these next 4 specs are still not for extreme conditions, because for extreme conditions, pretty hard to have an industry standard. Extreme conditions tend to require specifications set by OEMs or discovery by the end user of what grease will actually work in their extreme condition. Industry specs don't really have a place for extreme conditions. So what we have done here is we've established improved performance in 4 areas over the HPM Core Specification. So that's where we are with these specs. So we'll talk about the first one, and I hope when I go through these 4, I'll answer some of the questions that I deferred from earlier that were about water resistance and so forth. So determining water washout, that's the ASTM D1264. Well, we have that spec in the HPM limit, but we have a 10% maximum. And again, this by the gray shading, you can see it is part of GCLB. But we're more strict than GCLB in our HPM core spec, and now we're even more severe with a 5% maximum for the water resistance specification. D4049, determining water resistance of lubricating grease to water spray, or in other words, the spray off test. This is not in GCLB, it is not in HPM. This is an additional test to demonstrate water resistance. And of course, it's a different kind of water resistance than what the washout test demonstrates. This one is more of a wet adhesion test, and there was considerable discussion around the appropriate limit here. There was a lot of energy around having a 20 or 30% maximum limit, and this is when I think we got into the discussion of challenging but achievable. If you start specifying 20 or 30% maximum, you're probably talking about something like a steel mill grease or perhaps a paper machine grease where spray off is a serious issue. Again, we're not trying to create a grease that's good enough to go in a piece of steel manufacturing equipment necessarily, but a grease that is more resistant to water than the basic HPM spec. So we, after much discussion back and forth and review of data from the steering committee members, we settled on 40% maximum. Roll stability of lubricating grease in the presence of water, in other words, the wet roll test. This is a test where you look at the test method number, it's an 8000 method. It's not the newest test method in the world. There's not a huge body of data available for as we try to establish specifications. Everyone felt comfortable that this is probably a pretty good starting point, plus or minus 15%, but clearly we need to develop extra data, additional data from road testing for this test. And our next specification is HPM plus corrosion resistance. So required to meet the core high performance multi-use grease specification and have enhanced corrosion resistance. And this particular corrosion resistance, though we don't say it in the name or the acronym, the CR, it is saltwater corrosion specifically. We already have our distilled water corrosion tests in the HPM core spec. And now we've added 1 static and 2 dynamic tests. The D5969 is the saltwater version of the standard D1743 rust test, and we're doing it with 10% synthetic seawater as specified in ASTM D665. And again, this is a test that just has a pass or a fail rating. Then we've added 2 dynamic tests. These are both based on the M-Core test method, D6138. They're dynamic. The first one is using 100% synthetic seawater, as in ASTM D665. And again, with a fair bit of discussion back and forth on the appropriate maximum limits, we agreed on a 1,2. And what that means for those of you that aren't familiar is you're running 2 bearings and you're allowed to have one of them be a 1 and the other one be a 2. You can't have 2 bearings that both test at a 2 or you've failed. So you have to be at least 2 or better on one bearing, and you have to be at least 1 or better on the other bearing. And then the last test here is another variation on the M-Core saltwater test. And instead of using synthetic seawater, this uses a 1.5, what's the N? I'm drawing a blank. Anyway, it's about 3% sodium chloride. It's a sodium chloride solution. And this test is generally considered to be more severe than the 100% synthetic seawater test. Although that's not necessarily always the case, but it's generally considered more severe. And so we have specified a 2,3 as the maximum limits for this test. So our next specification, this has a lot of tests on it. This is probably one of the more important specifications is high performance multi-use plus high load specification designated by plus HL. So here we've taken a number of tests that were already in HPM or already in GCLB and created more difficult and more stringent limits. So the 4-ball wear test, standard conditions, but we have lowered the maximum limit from 0.6 in the HPM Core Spec to 0.5. There was a lot of discussion here that it may be challenging to meet the 0.5 with an EP grease that carries the 400 kilogram weld load that we show in the next line. So the road testing will be to evaluate that and make sure that the 0.5 is not too low for this high load carrying category. But we agreed widely with the 400 kilogram minimum weld load, and this compares to the 250 kilogram weld load in the HPM Core Spec. Then extreme pressure properties of grease using the SRV test machine. This is a completely new test for our specification work, not in GCLB. A test that has a decent amount of data. We thought initially there was not enough data to even set test limits, and that maybe this was too esoteric a test to include in our HPM plus HL specification. But after much discussion, we found considerable body of data. We recognize that it's an expensive piece of test equipment, but that there are a number of test laboratories available in the US and other parts of the world as well. So we did, after much discussion, agree to keep this test in. We're going to learn from this, and ultimately I think the world is probably moving towards SRV testing compared to some of the older technology 4-ball type tests. And we've specified there are several different procedures and temperatures available, so they are specified here. So we've got an 800 minimum Newton force limit established. Fretting wear, Gareth talked about this. This is a troubled test. It has had issues with precision for quite a while. It has issues with supply of bearings that are consistent with the bearings from previous years. So there's a lot of work going on within ASTM to fix this test. So here's one. This kind of goes back to my comments when we were talking about the elastomer compatibility test. Why don't we just say report only? Well, what we're going to do with this one, again, report only, nobody sees that data except the person that submits it in the NLGI. So instead of doing report only, we're going to offer provisional licensing until the test variation is addressed through ASTM. And provisional licensing means you can certify your grease as HPM plus HL with no fretting wear data. The fretting wear data that you would provide would be unreliable anyway at this point in time. So this is one where you'll get provisional licensing, and then once ASTM has the test fixed, which I couldn't tell you when that will be, my guess is it's probably a year. There is a fast path project going on to get it done sooner. So once the test is fixed, then we will go back to all of the holders of this certification and say, you now need to run the fretting wear test and submit data to actually get your certification moved from provisional to officially licensed. The last one here is another SRB test. So this is a fretting wear test by SRB. I won't discuss it much more than I did on the other SRB test. There was a sufficient body of data, I think, to establish a good limit and at these test conditions, and there are test labs available to develop that data for people to get certification. And the last of the specs is the low temperature spec. As noted by both Gareth and Mike, the original 4 enhancements were corrosion resistance, water resistance, high load, and long life. And we came to the conclusion that the long life specification is going to take several years to get developed due to the requirement for a new test method. And in the meantime, we learned that people would like to see a low temperature test specification. So we added LT, and this one, we've got a number of tests. None of these are in GCLB. We've got the low temperature torque test again, D1478, but instead of -20C, we have -30C with the same limits as we have at -20C for the HPM spec. The grease mobility test has been added. This is the US Steel method. We've got that specified at -20C with a minimum of 10 grams per minute. And again, due to a scarcity of data that we were able to lay our hands on, we include this in the requirement for some road testing to validate to make sure 10 is the right minimum at -20C. And -20C was chosen to be cold, but not frigid, not Arctic. There are issues trying to run that test at too low of a temperature, apparently. And then the final test is a DIN test method, the DIN being the Standards Association out of Germany. This is another sort of a version of the mobility test, but it is different. And we've come up with -30C as the appropriate temperature. And this test you run until you see what the maximum pressure is required to move the grease at -30C. And we've set that at 400, which is also in line with the DIN low temperature limits in their specifications. Okay, I'm going to look at the Q&A. On what base did you choose 400 kilograms for D2596? Why not 500 or 620? Good question, and one that got a lot of discussion. There were a number of folks that basically proposed the same thing. Why not at least 5, perhaps 620? We again decided that we are not trying to establish a standard for some extreme high loading like you see in the mining industry, for instance, which is where you come across numbers like 620 kilograms on grease specification sheets. We're just demonstrating better load carrying capability than the HPM spec at 400. If people want to claim a 500 or 600, they may want to specify, I think Joe mentioned this at the beginning, people may specify the HPM spec, or in this case, HPM plus high load, as a basis, and then provide enhanced performance on top of that, which would be certainly their choice. And they could claim HPM HL and still claim a 620 kilogram well load on their product data sheets. And so that would sort of position them as over and above NLGI's HPM plus HL. The high load appears to address high load, high speed. Was there any thought to the much higher load and lower speed applications seen in mining and heavy construction? In a sense, I think I've answered that. We are not trying to provide a grease specification suitable for use widely in mining and heavy construction. I think probably It would be suitable for some of the less severe versions of heavy construction, some off-road equipment perhaps, we're hoping, and that's to be determined if it's good enough. But again, people that want greases or want to sell greases for those applications are going to make many claims that would be over and above what we would make with HPM plus HL. Does the HPM plus HL possibly instigate the use of EP solids? If so, then there's a possibility of an antagonistic impact on fretting wear. That's a good question. We had that same issue come up during our interview process. And you can make HPM plus HL without solids. We're pretty darn sure of that. And the use of solids might be antagonistic to some of the fretting wear tests, for instance. And again, we're trying to be formulation or chemistry neutral. The spec is not intended to force you to use EP solids. If you do, and you can't meet the fretting wear spec, we're going to have to analyze that. If it comes back, the fretting wear spec right now is on provisional basis, so you won't have to meet it. If in time we find that that's difficult, we will need to reconsider. I mean, as I said before, these are going to be sort of live specifications that can be adjusted once we have learnings that sort of drive us to change our position. What about lubricant additives inside HPM grease? I'm not sure what that question means. Of course, there are probably going to be additives inside the HPM grease. Do you eventually envision products marketed listing multiple of these specs beyond the HPM? Absolutely. That is a really good question, and Gareth wants to answer this question live. So Gareth, you want to turn on your mic and answer this one?
Sorry, Chuck, where's the question again?
Do you eventually envision products marketed listing multiple of these specifications beyond the HPM?
Yes, so as we outlined in about 3 working groups ago, so 2018, there was a proposal to expand, once we've got through this, to other things like enclosed gearboxes and other greases as well. And so this is phase 1, effectively, of a wider reach to define specifications for greases for lots of applications.
Thanks, Gareth. And I'd like to say also that I've already presented 4 multiple specifications. We're already listing HPM plus CR, HPM plus WR. And yes, down the road, I fully expect that we will have some greases marketed that claim more than one of the add-on enhancements. For instance, HPM plus WR plus HPM, or I'm sorry, plus high load. There's no limit to that. The limitation, of course, is in being able to formulate to meet all these different specifications. But in theory, a grease could be HPM plus all 4 of the additional tags. Okay, if the fretting wear, there are 2 questions about fretting wear. One being, if fretting wear is problematic, could the SRV test be a replacement? Do we know what the precision is versus one test versus the other? And then another one, if the SRV 7594 gives some confidence that the fretting resistance is good, independent of D4170. These are great questions too. We really worked this issue extensively for quite some time. There was initial reluctance to include a test like the SRV that's newer and expensive, and everybody doesn't have one, and do we understand what the test results mean? And we found a lot of good test results and got comfortable with it, and found laboratories that will run it. So we kind of dismissed some of those concerns. And then we proposed, well, if these tests, the SRV threading test is a better test without precision issues compared to D4170, why don't we eliminate D4170 because of its problems? And the resounding feedback was, we can't not have D4170. We need to have that test. Everyone's familiar with it. We need to fix the test, yes, but let's keep it. My guess is that in time, and I mean down the road some years where we've seen lots of data in both tests, we may eliminate one of them. We may eliminate 4170, or we may find that they really give us a little bit different answers, because no two fretting tests are the same in terms of angle of contact, amplitude, speed. None of them are the same. And Joe Capara could talk for 45 minutes on the differences among the various fretting wear tests. They don't correlate with one another. So it's very possible that we keep them both, and hopefully the D4170 gets fixed. Can I speak at all to the precision of US steel? My understanding, there's significant reproducibility, which I assume means issues of this method, while repeatability may be accepted, but there's no published limits either. That's a real good question. That's one that needs work, and I think we have some precision from one of our team members that is repeatability. So I think we can go forward with the test. I think in time, if we continue to like this test and it seems to be viable, I think the time will come for us to revert to ASTM and ask them to reconsider this as an ASTM method with established precision. What are the issues you heard about low temp torque testing at -40°C? Well, we determined that -40°C, while it's certainly a requirement for automotive manufacturers and still a requirement, that's the wheel bearing low temperature torque that's required in GCLB. For our low temperature spec, we determined that -40°C is rather extreme, and we don't plan to kind of certify that a grease is going to work at -40°C with the LT specification. So that's why we backed off from the -40. What are the issues you heard? I answered that one. SRV will also provide an indication of friction parameters. True. So it is a plus to have that part of the spec. Absolutely agree with that. I think long term we're going to discover we really like the SRV tests and what they provide. The DIN flow pressure test is an excellent fence test for assessing low temperature behavior at -30 and -40. I'm glad to hear that you feel that way. Can we evaluate the water resistance property of greases if the change in the penetration value of two greases of the same magnitude, but one being positive and the other negative? Can we consider both of the same level? Wow, that's a good question. I guess if we've got our limits set tight enough so that we're not allowing excessive hardening or softening, then we're indifferent to whether it hardens or softens. We've got plus or minus 15% for the wet roll, but we're going to road test that. So that's going to be an interesting. It's always been an interesting question. What does a grease's resistance to water mean? Does it resist, repel water? Does it absorb water and not change in properties? So that's another great one, and I think we'll just have to make sure our limits are restrictive enough that some degree of softening or hardening is not excessive. Any control of solid lubricants inside HPM grease? No, we're not specifying a requirement to not have or to have certain chemistries. Do you know how many laboratories are offering SRV tests? There are at least 5 in the United States, and I can't speak beyond that. We can talk separately about what labs are available. And NLGI is going to work on that issue to make sure that we've got good, consistent service and so forth, and availability from these test labs. Will the information used to create limits shown today be available or published with the specification? This will be similar to an ASTM research report. I'm interested in the data to support the SRV fretting test specifically, as well as the wet roll stability. That's one I think we need to take back to the powers that be at NLGI. I think that might be a good idea. I think that would be appropriate, not necessarily published with the specification, but published as a paper, kind of like the paper that Tom Verdora did back in 1990, talking about the introduction of GCLB. We could do a paper talking about this introduction and provide some of that data to support our choice of limits. I think that's a great question, and I hope somebody in our group is noting that for future action. So these HPM plus XXX variations will be different classes of HPM. They will be additional certifications on top of or in addition to HPM. So depends on what kind of semantics you want to use in terms of how you call it. Is it a different class? Yeah, HPM plus CR will be sort of a different class than HPM. It's a compound specification with HPM plus additional claims. So I'm not sure if I've answered that one. Which elastomers do you recommend for testing in new and old specifications? I'm not going to answer that. I'm going to ask Gareth or Mike to answer that.
I can answer that. So in the current 4289, you have AMS 3217 2C, which is an NBRL, and you have 3C, which is a polychloroprene. And then in the new elastomer specification, because polychloroprene is only used mainly in automotive and it's not an automotive spec, we decided to stick with nitrile or NBR, and we're moving to a 28% nitrile content, peroxide cured, US available material that's specified in ISO. We're working out the final details, but that's where we're at.
Thank you, Gareth. Okay, with that, I think I've addressed everything that I've seen pop up in the Q&A, and I would like to now turn it back over to Joe Kaparick, who is going to tell us what's coming up next.
Thank you, Chuck. Excellent job. You, again, did all the heavy lifting here. So we are essentially, we're going from this point forward. Where are we going? I think it's been pretty well described today, but we want to make sure you understand the process, and that's kind of doing some of the fine tuning that Chuck talked about today. You can see, some of the road testing, some of the additional work on things like fretting wear that needs to be done. And some of the questions even raised today, I think, were some good questions, talking about things like a research report. From here, the plan is to do that fine tuning through the specification steering committee, and then take this back to the board of directors for final approval on the specification, and then start or continue, I guess, put more focus on the marketing of this specification. So getting the communication out to the stakeholders, getting it out to the industry that this is here. I am really glad to see that we've got 200 people here today who now are hopefully more aware of what we're doing and where we're at. And the idea is to make sure that we get everybody else aware of that by the rollout time next year. So going forward then, once I get this back under control, maybe. There we go. Oh, sorry. So going forward, the idea is to launch HPM in the core spec and the subcategories we talked about. But we also have immediately, we are continuing work on the high temperature, long life category. And as Chuck and Mike, I think, both mentioned, that's an area where we definitely need a new test rig. And possibly more than one, but I think at least a high temperature bearing test that is reliable enough to use in a spec like this. So the idea is to get that out there and then continue to work on the high temp long life category. That's probably optimistically maybe 5 years because of the need for a new test. Yeah, we'd like to push it faster, but it's got to get through ASTM. We have to get enough stakeholders willing to buy into that and start testing and purchasing equipment and things like that. So that may take up to 5 years. We're going to continue to refine the testing. We talked about some of the things today, things like fretting wear, things like SRV, some of the reproducibility issues. We're constantly working. I think you'll see a pretty good intersection of people within NLGI, within the NLGI community that are also active in ASTM. And so part of that activity is to continue to work on reproducibility, work on reducing issues that we have in those areas. So I think hopefully that continues to help us on this side with the specifications. But then also we want to be open to adjusting specifications or adding on to specifications as we see that need in the industry. We don't want it to be 30 years until the next update of specifications that are useful for the grease industry. And there were a couple of things that I noted while we were talking today. Maybe we weren't as clear, and I think Chuck and Mike and Gareth all kind of touched on different parts of this, but the idea here is not to have HPM be the magic grease that fits all multi-use categories. The idea is to help kind of have a conversation again. So if an equipment manufacturer has a special elastomer that they need for their equipment, maybe they get an understanding of how that grease is going to behave from the elastomer specified in HPM, but they're going to have to do additional elastomer testing for their application. We can't build in every elastomer or every heavy high EP testing for every category. It has to. We're aiming at kind of the broadest swath of the industry that will be useful then as a building block for them. So an equipment manufacturer can then spec something in and add additional tests that they need for their particular application, or a marketer can have the conversation that, hey, this has been certified by NLGI to meet these core specifications. Now we're going to build in some extra, or we think that it also helps you in this area on top of that. So that's up to that conversation between the user and the marketer or the manufacturer. But we're hoping to kind of make this make the conversation easier with this core specification set here. So, and again, I think it was mentioned, but the core specification, you would have an individual mark for HPM, for that basic HPM, and then you'd have a separate mark for water resistance, or a separate mark for corrosion resistance, or a separate mark for heavy high load. So those are separate pieces for each of those. There was also a couple of comments, I think, in the question and answer area about slides being hard to read today. I know, especially on the specification piece, with the smaller screens, depending on how you're viewing this, it may not have been easy to see. I think it was fairly easy on our screens when we were going through this. So hopefully not too many people had that issue, but we will have these slides available afterwards. So I think I have a couple more questions here that I'm going to jump to here. Is the committee willing to accept any changes in the limit set at this point? I think we are pretty well set. We've done a good long discussion with a lot of people, and as I think Chuck and Mike have kind of really spelled out, the process was pretty painstaking. We certainly are open to admitting some mistakes if we see that maybe there's a reason for that. But I think at this point we are pretty well set on what we're doing. There is still some fine tuning to do, as Chuck says, but I think at this point we're pretty close to finished. Do you have a file with the slides to send out? We're not going to send it out, I don't believe. Maybe Crystal can answer that later, but we will definitely be posting this on the website as a PDF, so that will be available there. You can certainly take that and a lot with some other supporting material as well. So that material will be available.
That is correct, Joe. We are just planning to put it on the website at this time and direct everyone there.
Very good, thank you. All right, and for each categories of HPM Plus, can you give us some example of the industry or applications that you intend to develop them for? So this kind of comes back to helping the conversation. We don't want to be, we can't be everything for everybody. And there may be certainly applications and industries that we're not even aware of that would find this useful. The hope is that by providing a core basis of performance and performance targets and specs, we are kind of helping that conversation again. We've told the end user what this grease will do, and they know because of the certification and audit process that it has lived up to a certain level of performance. Now, it's still up to a conversation between the grease marketer and the end user as to whether that's the correct grease for that application. That's not something that we can get into, but we can help that conversation, hopefully, with the HPM specification. The control of HPM registered in NLGI will be conducted in the same way as GCLB. Yes and no. So yes, it will be conducted in the same way as GCLB going forward, but what we have not always done in the past is a good job of auditing GCLB. I think it was pretty much a self-audit, but CQA is going to be taking on the certification and audit process for both GCLB and the HPM specification going forward. So you will see more information on that in the future, but that will be taken over by CQA, and hopefully that's going to add value to the specifications. Is licensing going to work similar to GCLB? That is, I think, what I just talked about. And we hope to officially launch this in January. So I guess that's what I mean by launching, is that we will be ready to have people submit for the specifications in January of 2021. The recording of this webinar will be available in your web suite. Some colleagues were busy now, but interested in this issue. And I believe that is correct, Crystal. We will have the recording available.
Yes, Joe, that's correct. The recording and the supplemental documents all available on our website.
Fantastic. Okay. And what is the timeline for HM Plus implementation adoption? So again, we hope to have the specification finalized within the next 2 to 3 months, approved by the board in September, and available for submissions in January of 2021. All right, so I believe that is all of the open questions that we have here. Hopefully we've answered everybody's concerns and questions, and great discussion, even in a kind of a difficult format to do that. But for additional answers, so today's slides, along with supporting material about HPM, we'll try to get any new material up there as well. And I think things like data or research reports, that'd be a great place to put that if we can decide what format that's going to be in. So that's at the NLGI website. The link is on here, but it's under High Performance Multi-Use Grease on the nlgi.org website. If you've got any other questions or comments, please feel free to contact any of the people that were part of today's panel. So myself or Dr. Fish, Mike Kunzelman, Chuck Coe, and Crystal obviously will know most of the answers to anything else that we don't. So there's the contact information there, and we do appreciate your time today and your interest. And the last piece that I'd like to leave you with then is the, oh, come on now, one more slide. Yeah. Yep. All right. Well, I lost the last slide. Maybe Chris may be able to bring it back up for me. But kind of fresh news, hot off the presses, is that we have board approval from the NLGI board to go forward with a virtual technical week, and that is going to be the week of August 24th. We will probably be seeing an announcement on that later today, potentially tomorrow, but you will see that shortly, probably in your mailboxes. We are going forward with the technical portion of the program you would normally see at our annual meeting in June. So we will have basic and advanced education courses on the Monday and Tuesday of that week. Wednesday, we will start off with our industry keynote speaker, Dr. Delacourt from NASA. We will also be doing our Grease survey. I think we have 13 technical presentations that are confirmed. a little bit longer than the normal ones because we have a little bit of extra time in this format. We'll be continuing that then on Thursday, and finishing up on Friday morning. We'll finish the technical presentations and then have an HPM panel discussion. That panel discussion will be a little bit more open format. Hopefully we'll have some additional information on HPM by then. I'll be able to share with you, but also a little bit more open question answer discussion from a little bit different angle to again talk more about HPM. So I will leave you with that, and again, you'll see that flyer coming out soon. But I appreciate your time today and your interest, and we hope that we will see you all again live sometime in the near future. But at the very least, hopefully you'll be able to join us at the end of August for the technical week. And thank you very much. Crystal, anything else we need to do?
No, that's it. Thank you everyone for your time today. We really appreciate your participation.
Okay, thanks again.